When we're solving rational equations that are set up like a proportion, they're easy to solve by cross-multiplying. First, remember that these terms make up a binomial, so if you'll put parentheses around there, that might help you remember to distribute 7 times 2x minus 10. So we have 7 times 2x minus 10 equals 11 times x minus 2. And then we'll go ahead and distribute that. Solve it just like you know to solve an equation. Subtract 11x, that gives us 3x. Add 70, that gives us 48. Divide by 3, that gives us 16. We always want to make sure that we check our answer in our original to make sure that it works. 7 over 16 minus 2 is 14. And on the other side, 11 over 2 times 16 is 32, minus 10 is 22. Both of these equal 1/2, so our answer is right. In this next one, it comes out just a little bit differently, but we work it in the same way. Let's put parentheses around the binomials first, so we won't mess those up. And now we have 1 times 11x plus 8 on one side, and on the other side we have x times 2x plus 5. Go ahead and distribute that. So that's 11x plus 8 equals 2x squared plus 5x. Since we see an x squared on one side, we probably are going to end up with something that we can factor and come out with two answers possibly. So let's subtract everything from one side and subtract it from the other side, so that we are going to have 0 on one side and a quadratic on the other side. 2x squared minus 6x minus 8. Now we see that we have something that we can factor. So this is 0 equals, we'll take out a 2. That leaves us with x squared minus 3x minus 4. And now we can factor that with x minus 4x plus 1. Solve these. X minus 4 equals 0, so we know that x equals a positive 4 and x equals a negative 1. Now let's check our answers to make sure that both of them work. All right, we're checking the 4 first. 2 times 4 is 8, plus 5 is 13. See if it is equal on the other side. 11 times 4 is 44, plus 8 is 52. And that reduces to 1 over 13, so that one checks out. Now let's check the negative 1. We have 1 over negative 2 plus 5 is 3, and negative 1 over negative 11 plus 8 is negative 3. These are both equal to positive 1/3, so that checks out. So those are our two answers. They both work. Well, now we've got something that looks different. We have different denominators. So we're going to do what we did in the previous chapter. We're going to find the LCM, the least common multiple, and solve this. So our LCM is one of each kind of factor. We need the 5 and we need the x. That's our LCM, is 5x. We don't need another x. We only need one of them. If we multiply both sides of the equation by the common denominator, that's going to help us cancel out the denominators. So I'm just going to put brackets around here. We're going to multiply every single term by 5x. We'll multiply this by 5x, and we'll multiply this by 5x. When I multiply 5x times 15 over x, the x's cancel out, and I'm left with 5 times 15 is 75. 4/5 times 5x, the 5's cancel out, I'm left with 4x. 7 over x times 5x, the x's cancel out, I'm left with 35. So now we're going to solve that just like we know to do. 4x equals negative 40, so x is negative 10, and I always want to check it to make sure that it works. So I have 15 over negative 10 plus 4/5 equals 7 over negative 10. Okay, let's find a common denominator here. Between the 10 and the 5, I have a common denominator of 10. So now I have negative 15 over 10 plus 8 over 10 equals negative 7 over 10. And that does work out. Negative 15 plus 8 equals negative 7. So that is our answer. Negative 10 is our answer. You try this one and then come back and check your answer. I'll help you out a little bit here. Remember, equals 3. This can be expressed as 3 over 1, so that might help you in looking at the problem. Okay, let's try another one, another kind. This one has a binomial. Remember, when you have an x plus a number, that has to stay together. So the two factors in this problem are x plus 7 and x. Well, remember, for our LCM, we need one of each kind. So I need the x and I need the x plus 7. It might be helpful for us to put a 1 underneath that 1 just so that we can see that it is a fraction. Now let's multiply all of our terms by the LCM, x times x plus 7. I'll multiply everything here by our common denominator and here by our common denominator. We do this so that our denominators will cancel out. So when I'm multiplying the LCM times 12 over x plus 7, the x plus 7 cancels out, and I'm left with 12x. Over here, I have 1 times the LCM, so that's going to be x times x plus 7 times 1. We don't have to write that. Now I have the minus 12. Right here, the x's cancel out, and I'm left with 12 times x plus 7. Now I'm going to go ahead and distribute and combine like terms. Combine like terms on one side, and then subtract the 12x from both sides. So let's see what I have. 0 equals x squared minus 17x minus 84. Now we have something that we can factor. Remember, when we're factoring negative 84, we want to know two factors that will add together to give us the negative 17. So if we say 4 times negative 21, that should give it to us. So we have x plus 4, x minus 21. And that's going to give us x equals negative 4 and x equals 21. Let's check it back in our original, the negative 4 and the 21. So 12 over the negative 4 we'll do first. So negative 4 plus 7 is 3. Negative 4, x is negative 4. Let's see what we've got. 12 over 3 is 4 equals 1 plus 3. That one works, so negative 4 is one of our answers. Let's see if the 21 is one of our answers. I'm checking 21. 12 over 21 plus 7 is 28 equals 1 minus 12 over 21. This reduces to 3 over 7 equals 1 minus 4 over 7. 1 is the same thing as 7 over 7 minus 4 over 7 is 3 over 7, so that is one of our answers. So our other answer is 21. These are our two answers right here. Both of them work. They don't always both work. We're going to come to one of those examples in just a moment. Well, this one comes out just a little bit differently. We have something in it we need to check. So remember, our binomials stay together. So our LCM in this one is just x minus 2. We have an understood 1 here. So if I multiply everything by the x minus 2 in order to eliminate the denominator, x minus 2 is going to cancel here, so I have 5x equals 7x minus 14 because we multiplied the 7 times the x minus 2. And then we have plus, and it cancels out here, plus 10. So I have 5x equals 7x minus 4. Subtract 7x from both sides. That gives me negative 2x equals negative 4, so x equals a positive 2. Now remember I said we wanted to check and make sure that it works. We've got to check and make sure that it works. So 5 times 2 over 2 minus 2. On the other side we have 10 over 2 minus 2. Well, here's something that we may not know. 2 minus 2 is 0. We can never have 0 in the denominator. So this is an extraneous solution because we can never have zero in the denominator.